Okay, Assalamualaikum class. So hopefully when you listen to this video, you have finished the first part of this topic, which is topic model evaluation matrix. The first part talks about the introduction on of the evaluation, introducing the why we need to evaluate our model, and then to understand what is underfit and what is overfit problem. So in this video, we are going to look into the second objective in this topic, which to introduce model evaluation matrix focusing on a confusion matrix. Okay, for evaluation matrix, there are for the classifier there are several evaluation measure that has been used in research. So antaranya ialah accuracy, or we know that as recognition rate, and also the and then we look into the misclassification rate, berapa persen, kita nak tahu berapa persen classifier kita tersalah classify or tersalah predict, and also the sensitivity or true positive rate, how good our classifier in recognizing the true positive value, and also the rate for true negative or the rate of how many percent, or what are the the kebolehan of our classifier model to classify other classes than TP ni. So contoh TP kita cerita pasal awak ada A dengan B. So awak ada kelas A, kelas B. So TP mungkin cerita pasal A, how good our classifier in classifying our data that belongs to class A, and specificity talks about how good our classifier in classifying our data in class B. So itu sensitivity dan specificity. And then kita ada precision, kita ada F1, F score, and then kita ada F beta, and so on. So evaluation measure, not that some measure are known by more than one name. Contohnya ada yang sama seperti kalau awak tengok macam error rate sama dengan misclassification rate, semua dia samalah. Okay, so the first thing yang ada dalam saya cerita dalam kelas lab hari tu, bila kita sebut dalam classification, ada dua evaluation measure yang selalu digunakan. Yang pertama ialah we look at the accuracy, and second is we use confusion matrix to evaluate our model. So in this slide, we are going to understand what it is, what type of information, what are the information yang ada dalam our confusion matrix. So the first thing that you have to note is you have to understand your table, where is your predicted class and where is your actual class. So if we look here, kita nampaklah yang blue in color is the predicted class, so black in color is actual class. So when we want to read this matrix, so ada 4 values. Bila kita cerita, kalau kelas kita hanya ada 2 class, so our data kita ada 2 classes, there are 2 classes in our data, so our confusion matrix might consist of 4 variable atau 4 parameters, which are, it will have true positive, true negative, false positive, and false negative. So what are they? True positive is when the actual data is positive and our classifier predict that data as positive. Okay, so it is a positive and our classifier predict it as a positive. And then what is true negative? True negative is when our actual data is negative and our classifier predict it as negative. Okay, next is we are going to look at the false negative and false positive. False negative is other way around from true positive. So maksud dia, so the actual data is positive, however our classifier predict that data as negative. Okay, and the second one is false positive. So false positive ni sebenarnya apa? False positive ni adalah the actual data is negative. However, our classifier predict it as a positive. So it becomes false positive. So we are going to look at the example how to read this situation. So for example, Buy's computer scenario. Suppose that we have a table with the information of when a customer at All Electronics, wants to buy a computer or not. Using this table, we can construct a confusion matrix table. So contohnya kalau ada orang pergi dekat kedai kan nak letak barang elektronik. So this is our confusion matrix. Okay. So dia punya classes ada dua. Buy computer equals to yes, buy computer equals to no. So notice that color in red is the actual class, which actual data. Buy computer equals to yes, this is the actual data. Buy computer equals to no, and these are the actual data. And the color in blue, okay, the yang row in blue ni, itu adalah the predicted class. So when we look at this data, we can see that, okay, so there is 6,554 data. Dia punya actual dia memang nak beli komputer and it has been predicted as yes. Okay. Ni adalah true positive. Okay. And there is 46 data yang mana dia sebenarnya nak beli komputer but has been predicted as no. Okay. So it is false negative. Okay. Dia nak beli sebenarnya 46 orang ni nak beli sebenarnya komputer. The actual data is they are going to buy a computer. However, our classifier has wrongly predicted them as no. Okay, our classifier tersalah predict orang ni sebagai no. And then we look at the second one is it is actually negative and ataupun buy computer equals to no and has been predicted no. Okay, and this is at the end, and this is actually the last one is actually yes but has been predicted. So from here, if you want to know how good this classifier recognize yes, okay, macam mana kita nak tahu betapa bagus dia recognize this model, recognize buy computer equals to yes or predict buy computer equals yes. So kita ambil TP, which is 96954 divided by P. P is the total number of buy computer equals to yes. So total number of buy computer equals to yes ialah ini. Maksudnya kenapa 46 ni jadi buy computer equals to yes? Ya, sebab 46 orang ni, 46 data ni sepatutnya dia adalah yes. Tetapi apa yang jadi? Dia jadi bawah no sebab the classifier has predicted it as a no. So to get the total number of positive ataupun yes, kita kena tambah dengan 954 campur dengan 46. Then you will get this value 99.34. Okay, so same goes with this one. Okay, this is the how good our model classify by computer equals to no. So yang ni cara dia ialah kita ambil 2588 divided by 2588 plus 412. Then you get this value. Okay. Accuracy macam mana accuracy? Accuracy dia ialah you tambah yang ni berdua TP campur TM divided by 10,000. Sebab accuracy dia kira berapa banyak the model can classify our data correctly, secara tepat. Okay. So these are the formula of accuracy where TP plus TN di total number of positive. Yang tanya adalah correctly classify lah, divided by the total number of data yang ada. So this is the labeling lah, yang mana satu TP, yang mana satu TN, mana satu P, mana satu N. Okay, look here. So instead of accuracy, so kita akan tengok macam mana sensitivity lah. So sensitivity allows you to look at the class imbalance problem. So accuracy cerita mengenai the overall performance of your classifier model. So bagus ke tak secara overall. Sensitivity allow you to look at the class itself. So how good your classifier in predicting the certain classes. So these are the formula for calculating sensitivity, and these are the formula for calculating the specificity. Okay, class. Okay, so boleh tengoklah nanti, dan kita dah detail out pun during the lab class. And then the next measurement that we can use is precision and recall. Precision, it looks at the exactness, what percent of tuples that the classifier label as positive are actually positive. So macam mana nak kira precision? TP bahagi dengan TP plus FP, or TP boleh bahagi dengan P. Ini. So dia tambah ni, dua ni, true positive campur FP. So you akan dapat P ni. Okay. Whereas completeness, look at the what percent of positive tuple di classifier label of positive. So yang recall, dia tengok berapa persen asalnya positif dah berjaya di label sebagai positif. Sebenarnya it doesn't mean nak tengok positif ke tidak. Kita tengok classes itself. Contohnya kalau sini A, so class A kat sini kan. So kita tengok berapa yang dah diklasifikasi sebagai A divided by asal dia A memang diklasifikasi sebagai A di plus dengan selain daripada yang diklasifikasi sebagai A, yang bukan A tapi telah diklasifikasi sebagai A. Contoh kalau kat sini ada 3 kelas, so ia akan jadi FA, FB lah. FB dengan FC lah, FP tu. Okay. So, recall pula dia tengok berapa persen tuples di classifier label as positive. Berapa persen yang berjaya di label as positive. So, sebenarnya untuk recall, dia sama dengan TP divided by XP, which is the sensitivity. Okay. So, these are another example. Dalam kes ni, example yang diberi adalah, label dia adalah cancer equals to yes or cancer equals to no. Which is label dia adalah yes or no. So, kita tengok kat sini, atas ni adalah predicted class, dan yang tepi ni adalah actual class dia. So, kita boleh tengoklah label TP and FP. So, kita tengok macam mana sensitivity, berapa sensitivity, specificity, and also the accuracy. So, what we can say from here, we can say that this is the very high accuracy. The accuracy is more than 90%, which is tinggi lah, 96.4. Okay. However, the ability to classify, okay, cancer equals to yes, is very low, which is 30%. Okay. Whereas to classify cancer equals no is very high, and it is acceptable. So in term of precision, okay, precision and recall is very low. Kalau kita tengok precision and recall for cancer equals to yes. So precision and recall here referring to precision and cancer for cancer equals to yes. So precision and recall for cancer equals to yes, kita boleh tengok pun adalah sangat rendah. Okay. Another measurement yang boleh ada adalah F and F beta measure. So F measure ataupun dipanggil F1 atau F score, kita nak tengok harmonic mean purata of precision and recall. Kita nak tengok berapa dia punya purata antara precision and also recall. Okay, so kalau ingat precision adalah how many percent. Okay, kalau ingat precision is what percent of tuples that the classifier label as positive are actually positive. So kita nak tengok antara berapa persen yang sebenarnya adalah cancer equals to yes dan sebenarnya adalah yes. Yang kita label yes tu adalah yes. Dan recall adalah berapa persen tuples ataupun data yang classifier berjaya predict dengan betul untuk yes. So dia adalah kita nak tengok the mean purata dia. So itu F measure. Dan F beta, the weighted measure of precision and recall, assign beta time as much weight to recall to precision. Okay, so kalau nak baca detail pasal ni, boleh pergi ke website ni lah. Okay, so summary, kita dah tengok pasal confusion matrix, accuracy, error rate, sensitivity, specificity, precision, recall, F and F beta measure. So difference. So kita jumpa dalam next slide. Thank you.